Describe concepts of wired and wireless quality of service components, and quality of service policy. Remember that quality of service helps you if you have bandwidth saturation, high latency jitter, that is a variation of latency, packet loss due to congestion. You can choose among many quality of service models. For instance, best efforts means actually not implementing any quality of service protocol, but if, for instance, you have bandwidth saturation, you just go and buy more bandwidth, and if you have congestion, just go and buy faster rate hardware. But if you cannot do that, and you can choose the integrated services model that involves the configuration of the resource reservation protocol. Or you can choose the differentiated services model that involves what we're going to talk here. The first step in the differentiated services model includes the classification and marking of your packets and frames. The classification means distinguishing streams using descriptors. And so you will distinguish voice streams from video streams, from database transaction streams, from internet navigation streams, and so on. And the descriptors for distinguishing these streams can be the source IP address, the destination IP address, the protocol number, the source port, the destination port, and so on. There are products such as MVAR version 2 that can distinguish these streams for you. So it can happen that there are so many users in your network that the amount of different streams can become overwhelming. So MVAR version 2 can't find those streams for you. It will have to run for some time in one or several equipments. So MVAR 2 will, after some time elapses, will tell you exactly what streams are running through your network. For instance, it can tell you that you're running voice sessions, but they are exactly zip voice sessions. Or if you're running video, it can tell you exactly what type of video streams are running through your network, if they are coming from YouTube, if there are corporate video streams, and so on. So you don't have to distinguish all your streams by yourself. You can use these products. Next, you will have to do marking that involves actually changing the field values within the headers of your frames and packets, and changing these values according to the type of stream they belong to. So you can choose to, for instance, put the value of 5 to all the frames that belong to voice streams. Or, for instance, put a value of 4 to all the frames that belong to video, corporate video streams. And place a value of maybe 1 or 0 to all the frames that belong to YouTube streams, and so on. So the trust boundary is the place in the network where you will be actually doing this classification and marking. It is a boundary, but because it must be the device that lies closer to endpoints but remains under your control. So, for instance, the device that is closer to user might be that user laptop, but if you're not under control of their laptop, that usually are not, you cannot see that laptop as a trust boundary. So you will have to probably use an IP phone or an access switch as the trust boundary in order to do the classification and marking for your frames and packets. So if you're going to do marking in layer 2, you will need your frames to be tagged with the .1q tags. Otherwise, a normal Ethernet frame has no field where you can place your quality of service markings. So you will need, for instance, the priority code point field that is defined in the .1p standard in order to mark your Ethernet frames. It is 3 bits wide, so it provides 8 possible values, or QoS. These are known as QoS. So you can set 0 for background, 1 for best effort, 1 for excellent effort, 3 for critical apps, 4 for video, 5 for voice, 6 for internet network control, and 7 for network control. You can also use the drop eligible indicator field in case you want to check frames that are eligible for being dropped. Now, if you want to mark your packets at layer 3, you can take, for instance, the IPv4 example. If you are using IPv4, in your header, there is a field that is known as TOS, which is 8-bit wide. Historically, the first marking method was known as IP precedence. And the IP precedence method will only use 3 bits from the 8 bits available. And however, it was not customary to use the values of 6 and 7. The more recent standard, which is the differentiated service standard, establishes that the differentiated services code point will exist within the TOS field, and it uses 6 bits, so that will give you 64 possible variations for your markings. The 2 remaining bits are known as the explicit congestion notification. You can use for personal cases within your network the 64 values, but the actual standard will tell you that you can either choose clock selector per hop behaviors or other 14 per hop behaviors. So if you choose to use the class selector per hop behavior, you will be only using 3 bits. This is known as class selector and is backward compatible with the IP precedence. The other 3 bits that the DHCP standard uses will be set to 0. So you can also choose to use default forwarding, assured forwarding, and expedited forwarding per hop behaviors. In that case, you will have 1 value for the default forwarding per hop behavior, which is all zeros, and 12 possible combinations with assured forwarding, and 1 value for expedited forwarding. Expedited forwarding is used for normally for voice traffic. The assured forwarding number 4 is usually used for video, and the other assured forwarding levels are used for critical applications such as SQL transactions and any other critical application or business critical application within your network.